There's a slight variation of the binary search algorithm that I wanted to talk about because it can come up in interview problems and it's actually pretty simple to understand once you know it. It goes back to the idea I was talking about earlier, where let's say we were guessing a number between 1 and 100. In this case, we're not necessarily given an array of all the numbers from 1 to 100 in sorted order. That's not the problem that we're given. We're just given a range of values, and in this case, we need to guess the correct number. So in this case, we're not actually given a target either, where we're given some target, let's say 10, and we have to find the index of that. That's not the problem either. We're not given a target. Our goal in this case is to search along this space of values, this range of values, and find that correct value where that n value, whatever it happens to be, satisfies the conditions. And in this case, that would mean that n is the secret number that you're looking to guess. But in other problems, it might be something different. In this case, it's just a guess. There's nothing special we have to do with that n value, but what it could be is we're searching this range of values and we need to check if n satisfies some requirements. So let's say we have some kind of dummy function which calculates if n is correct. It is the value that we're looking for, and this function could have anything inside of it. It could be some computation, it could be, any kind of algorithm, but that's the idea here. But in our original binary search, we were just checking that value. We were checking n, we were checking if it's equal to the target. So this is sort of a more general case. For the original case we were looking at, our is correct would basically just check is n equal to the target, but it could get a lot more complex than that. So this is the general template that you might end up using. That's what I'm going to be talking about now. And it's very, very similar to the original binary search. I just think it throws some people off guard because they've never seen it before, which is why I'm showing it to you now. So this is a sort of template we can use to solve these range style binary search questions. Now this is Python code, but we're mainly focused on the main ideas of the algorithm, not the exact syntax. Now for this binary search, we're going to be given a range of values, let's say, and we're given a lower bound and an upper bound. We're not given an array, notice that. And the rest of the binary search is going to be pretty similar. While our low is less than or equal to our high, we're going to perform binary search. We're trying to guess the number between 1 and 100. We're going to calculate the midway point because we know we want to eliminate half of the possibilities every single time. So 1 plus 100 divided by 2 is going to give us a value of 50, somewhere in the middle. Now, since we're not given a target, how do we know if this is correct or not? Well, it's going to depend on what type of problem you're solving. But either way, let's have a helper function that's going to decide it for us. In this case, I'm calling it is correct. We pass in a single number, and then this function is going to somehow compute for us if our guess is correct. And if it's not correct, we do need to know, was our guess too big or was it too small? So that's for this specific example, but in other types of problems, this helper function could have some different type of computation. In this case, though, you can see I've hard coded it so that if n is greater than 10, we're going to return 1, which indicates that our guess is too big. If n is less than 10, I'm going to return -1, which indicates that our guess is too small. But if we execute the else case, that means n is exactly equal to 10, so we return 0. That means our guess was correct. So in this case, I've hard coded it such that 10 is the target value that we're looking for. But of course, there could be different types of more complex computations that we do. So in this case, for our guess 50, it's too big. We're going to return +1. So our is correct is going to be greater than 0. So then we know our guess was too big, so we're going to update our high value to be mid -1. So our guess, which was mid, is 50. So now we're going to update high to be 50 - 1, which is 49. We eliminated half of the possibilities. And now we go back up to the loop. Low is less than or equal to high. Let's recalculate the midway point. 1 plus 49 divided by 2. That's going to give us a guess of 25. We're going to call is correct. And in this case, our guess 25 is greater than 10, so we're going to return +1. This part is going to execute again. So That means our guess was too big. We have to update our high once again. Our high is 49. We're going to set it to be mid minus 1. So it's going to be now 25 minus 1, which is 24. And repeat. Take these two, add them together, divide by 2. Our guess is going to be 12. We're going to call is correct. 12 is still greater than 10. So our guess was too high once again. We're going to update high to be 12 minus 1. It's going to be 11. So now our high is 11. We re-execute the loop, add these together, divide by 2, we get 6. As our mid, we check, is 6 correct? Is 6 greater than 10? Nope. Is it less than 10? Exactly. So we're going to return -1. So which one of these two is going to execute? The bottom one, because is correct is less than 1. Because is correct is less than 0. So now we're actually going to update our low pointer because our guess was too small. We're going to update low to be mid plus 1. So our low is going to be 6 plus 1, which is 7. And at this point, you can see how the algorithm is going to progress. Add these two together, divide by 2. Our mid is going to be 9. Is that too big? Nope. Is it too small? Yep. So we're going to take our low, set it to mid plus 1. So our low is going to be 10 now. So now, finally, we're going to take these two, add them together. Our guess is going to be 10 plus 11 divided by 2, so that is going to round down to be 10. So our guess is 10. We're going to check is correct. Is it greater than 10? Nope. Is it less than 10? Nope. It's exactly 10, so we're going to return 0. This isn't going to execute. This isn't going to execute. Our else is going to execute, so we're going to return 10. That was the result we were looking for. We weren't looking for the index. We were just looking for what is the correct value. It turns out to be 10. So of course, this is very simple, straightforward binary search, just that we're not given an array, but the time complexity is still going to be the same. So the big O time complexity is still going to be log n. But in this case, what is n? Before, n was the size of the array that we were given. In this case, n is just the range of values. So since we're going from 1 through 100, the n is basically 100 in this case. If it was 1 through 1,000, it would be 1,000. It's the range of how many values we're running binary search on. I hope this gave you a decent understanding of how binary search can have multiple variations and how, in general, this method could be extended to do a bunch of different things while keeping the core binary search template still the same.